Chandrayaan-2 is the second lunar exploration mission, developed by Indian Space Research Organisation. In this video, I am explaining everything about Chandrayaan-2 and its associated equipments, orbiter, lander and rover. The mission was launched to the Moon by a GSLV Mark III launch vehicle on July 22, 2019. The major objective of this project are to demonstrate the ability to soft land on the lunar surface, and to operate a robotic rover on the lunar surface. Major scientific goals of this project are lunar topography, which includes the stereo image analysis of lunar surface. Second is mineralogy, which is the scientific study of chemistry and physical properties of minerals on lunar surface. Third is the elemental abundance, which is the study of occurrence of the chemical elements relative to all other elements in a given environment. Fourth one is lunar exosphere, which is the study of lunar atmosphere. Final one is to identify the presence of water and hydroxyl groups on the lunar surface. The major components of Chandrayaan-2 are the orbiter, which orbit the Moon on a polar orbit at an altitude of 100 km. Next is the Vikram lander, which detach from the orbiter and descended to a low lunar orbit. Last one is the Pragyan rover, which is a robotic device. After the rocket reaches space, the uppermost portion of the rocket separates and releases its payload. The orbiter lander module will conduct a series of 5 complex maneuvers around the Earth to build up momentum. The Vikram lander detached from the orbiter and descended to a low lunar orbit using its liquid main engines. It then performed a comprehensive check of all its onboard systems before attempting a soft landing that would have deployed the rover, and perform scientific activities for approximately 14 Earth days. Now I will explain more about orbiter, lander, rover and its associated equipments. The orbiter, which is a box-shaped craft, carries 8 scientific instruments. The total orbital mass is 2,379 kg. It occupies a 1,000-watt solar panel for power generation. The orbiter can communicate with Indian Deep Space Network and the Vikram lander. The scientific instruments occupied in the orbiter are X-ray spectrometer, to determine the elemental composition of the lunar surface, solar X-ray monitor, for mapping major elements present on the lunar surface, synthetic aperture radar, for probing the first few meters of the lunar surface for the presence of different constituents, including water ice, imaging IR spectrometer, for mapping of lunar surface over a wide wavelength range for the study of minerals, water molecules and hydroxyl present, quadrupole mass analyzer, to carry out a detailed study of the lunar exosphere, terrain mapping camera, for preparing a 3-dimensional map essential for studying the lunar mineralogy and geology, dual frequency radio science experiment, for studying electron density in the lunar ionosphere, orbiter high-resolution camera, for scouting a hazard-free spot prior to landing. It will later help prepare high-resolution topographic maps and digital elevation models of the lunar surface. The lander, which has an orbital mass of 1,471 kg, and it occupies a 650-watt solar panel. It can communicate with Indian Deep Space Network orbiter and the Rover. The lander will detach itself from the orbiter to make a soft landing on the Moon, and will then release the rover onto the lunar surface. The payloads on the Vikram lander are seismometer for studying moonquakes near the landing site, thermophysical experiment for estimating the thermal properties of the lunar surface, RAMBHALP Langmuir probe for measuring the density and variation of lunar surface plasma, a laser retroreflector array for taking precise measurements of distance between the reflector on the lunar surface and satellites in lunar orbit. Pragyan rover carries two instruments to determine the abundance of elements near the landing site: laser-induced breakdown spectroscope, LIBS, and alpha particle-induced X-ray spectroscope. The rover, which is a six-wheeled vehicle, also contains a 50-watt solar panel, and it can travel up to 500 meters at a speed of 1 centimeter per second. Rover communicates directly with the lander and sends the information. The expected operating time of Pragyan rover was 1 lunar day, or around 14 Earth days, as its electronics were not designed to endure the frigid lunar night. So, this much about Chandrayaan 2, and thanks for watching.